Hello and welcome to a little bonus video on some material that we don't normally cover in class that I thought would be really helpful for you guys as you work on your group project, getting ready for the last semester. So I want to talk to you guys about regression, and we learned how to use Excel to complete regression. We learned how to use SPSS to complete a regression, a linear regression. But I also want to show you how to use another type of application. I want to show you how to use scikit-learn and Python in Jupyter Notebooks in order to create a regression. So we're going to use a cool new method that'll give you pretty much the same results, but just another modern technique that you can add to your repertoire that will help. So we're going to use Python with a couple Python libraries in Jupyter Notebooks to do the same kind of regression that we could do in Excel. So if you look at this data set, it should look familiar. This is the data set that we used, which is a pretty standard set that you'll see all over the net or whatever, that we could use to try to predict home values. So what we've got is square footage of a home and the value of a home, right? So square footage of a home, value of the home. And what we want to do is create a regression using this historical data to try to predict or build a model that will tell us what the home value of a house will be based on whatever we've got already. So let me quickly remind you of how we did this in Excel. There's a couple different ways you can do it. So really quickly here, I could jump in and create a scatter plot. There you go. Now that'll be familiar. So we'll do this in Python in just a few here. And I can jump over to trend line, linear. Let's go with more options instead. There we go. We'll click linear here. We'll go down and we'll display equation online and display R square. Now, really, this alone is going to give you the regression, right? Because this is the linear regression formula right here, right? So y equals mx plus b. Okay. So, for example, if I had a 5,000 square foot house, okay, all I would need to do is take the 99.64 times 5,000 plus 48,053. And that's going to tell me that the estimated, there you go, the estimated home value of a 5,000 square foot house based on this particular set of historical data is 546,253. In this linear equation, right? So y equals mx plus b. 99.64 is the slope of this line. Okay, and this is called an OLS line, and 48,053 is the intercept of the line. So slope and intercept, and in Excel you have a function called slope that you can use that would calculate that same 99.64. You also have a function called intercept that would do much the same thing. And we'll do that same thing in Python here in just a second using Jupyter. Okay, so this is our data set. Now this data set, I'm actually going to need to, well, I'm not going to save this. So we're going to call this Excel file from Jupyter Notebook. So we're going to use this file to create this data. Now let me jump out of this, and I've got an open instance of Google Colab. So now this will be the first time you've heard me talk about this. So let's talk Python basics for just a second, or working with Python and doing some machine learning basics. So when you work in machine learning, when you work in Python, get out of here, Bing, you need something called an IDE. An IDE, oh boy, we're just going to keep getting these email pop-ups. An IDE stands for Integrated Development Environment, and there's a million of them. Oh my goodness, get out of here. There's a million of them that that you have out there. So one of the really popular ones for data science is called Jupyter Notebook. Now you can install Jupyter Notebook on your personal computer, and you have to install Python in order to run that as well. Now, a couple of things about that are less than ideal is that you have to set up just the right environment for whatever project you're working on. You have to make sure you have the right Python libraries installed, and you have to continue to update them. And if they get out of whack for some reason or another, you can have struggles. So enter Google Colab, which, by the way, to get to Google Colab, just open up Chrome or Firefox, and you're going to go to jupyter.research.google.com. And what that is a cloud-based version of Jupyter Notebook. It is a cloud-based IDE, integrated development environment. And for those of you that have never used this particular one, don't worry, this isn't all that different from using the VBE in Excel, right? The Visual Basic Editor as a development environment, or using Visual Studio Code if you're working in Visual Basic, right? Every programming language kind of has one. So that's what Google Colab is. It is an awesome tool. It is totally free. You do not have to pay if you don't want to. You can pay for some upgraded features that are handy dandy if you need them. But ultimately, you can do most of the things that we would do in this class without ever having to pay to upgrade to get better cloud-based hardware. So better GPUs, better TPUs, less time between timeouts. If you leave this thing stagnant, it'll time out on you just like any other website. So this is Google Colab. Right. So just to give you an example of how this works, I can just literally start typing, import pandas as PD. And you may not even know what pandas is yet. But if I write this little line of command here, if this little command line for Python, and I hit Shift Enter, it's going to automatically work inside Google Colab, which is a beautiful thing. So you don't have to do anything on your own machine. You can work this from the cloud. It is platform agnostic, so you can run Mac, PC, Linux, or whatever. You name it, you've got it. Okay. So what we need to do ultimately, and I'll just get rid of this for now, is we need to access our data file, the file that's got all of the stuff in it that we want to work with. Now, what you're going to do if you're using Google Colab is you're going to have to put that file on your Google Drive. Now, at our university, you have access to Google Drive and Google Colab using your university email. You're going to want to do that. So go to Google Drive, take that Excel file that we have that's available for you out on Canvas, drop that on your Google Drive. That's step one. So now the next challenge is, how do you actually connect to that? Well, what we're going to want to do is actually mount our Google Drive inside Google Colab, which has gotten a lot easier than it used to be. Now that sounds scary, but basically we just need to connect this cloud-based instance to whatever file it is that we want to work with. We need to link those things up. Okay. Not hard, sounds complicated. Here's what you want to do. So here's my cursor right here. I'm going to go over here to my folder. I'm just going to click. And if I click right here, see the little Google Drive folder, I can go here and it says, do you want to connect to Google Drive? Yes, I do. It is that simple. Now on my Google Drive, I've created a folder called Regression. Okay, so it's mounting right now. It may take a second because I got a lot of stuff floating around in there. There it is. All right, so here's my drive. And there's my drive here. And on my drive, I've got a lot of stuff floating around in there, but I've got a folder called Regression. And in Regression, I've got my home prices file right here. Okay, my home prices file. So what I'm going to do, and note that it's content/drive/my drive. And then from there, I'll go to Regression and my home prices right here. Okay, so don't worry about that for now. For now, what we're going to do is we're going to import some Python libraries. So what is a library exactly when you're working in Python? You hear people say it all the time, right? Oh, I like to use NumPy, or I like to use Pandas. I use scikit-learn or matplotlib. Well, think of a library like a set of skills that you can load into the Python environment. And when you load those set of skills into the Python environment, there are all these new things that you can do. Now, the thing that makes this confusing is not only do you have to install them if you're using the IDE on your personal computer, right? You would also need to load them into your specific workbook that you're working on, this specific Jupyter notebook that we're working on. So the good news is, for most of the things we're working on, we won't need to install anything if we're using Google Colab. So a lot of the libraries are pre-installed, so it doesn't require any of that headache of having to install before you jump in to get started, right? It's just all there for you, which is really great. So all we need to do is start connecting to these libraries, importing them into this notebook. So we need a few in order to do this regression. And the first one we're going to need is Pandas. So we're going to go import Pandas as PD. So what does that mean when I start typing? So import, that's a given, right? That's us importing the specific library that we want to use into this Jupyter notebook. So this specific instance, this application that we're creating. So where I've typed as PD, that's an alias. So what that means is, instead of me having to type the word pandas every time I want to use a skill or an attribute from inside this library, it's literally just going to be me typing PD instead of typing, pandas.read _ Excel, things like that. So that's all that means. It seems complicated, but you do it once or twice and you'll get it. So I don't know if we'll need it or not, but I'm going to go ahead and import NumPy. And again, so now test what we've learned, right? So when I type as NP, what does that mean? That is an alias, right? So import NumPy as NP is an alias. So now there are a couple that we're definitely going to need. So we're going to import something called matplotlib .py plot as PLT. Okay, matplotlib is basically going to give you your ability to graph the data, similar to that graph that we inserted, that scatter plot we inserted inside Excel. So again, that's 3 different libraries we've loaded so far. And then we need the big one. The big one, you'll hear me, I go back and forth. It's scikit-learn. You'll hear people say sklearn, but it's really much the same thing. So we're going to go sklearn, and that's going to give us our ability to load a linear model like so. Okay. And there we have it. So now what I just did is I hit Shift Enter. And what that did was it ran that particular line of code and then it advanced to the next line of code. So let's talk about what the Colab library looks like. So first of all, you're in a virtual computer basically. So you've got a virtual disk, you've got virtual RAM, and each one of these little rows here, think of that like command line, or not command line instances, but every time you write code, you can execute the code by hitting Shift Enter. Okay, so I can type code here, but it's not going to do anything until I hit either Enter right here to run the cell or Shift Enter, which will run the cell and advance to the next one. Okay, so why do we need Pandas first? So what is Pandas? Pandas is kind of like the Python version of Excel. You can do much the same stuff in Pandas that you can do in Excel. It's really, really nifty. And it works in something, instead of called workbooks, they're called data frames. And a data frame is basically like a workbook or a page of a workbook inside, or excuse me, a worksheet inside a workbook in Excel. So now in order to do this, I'm going to need to read that file that I've got loaded in my Google Drive. So I'm going to start off by just simply saying, we'll go with DataFrame equals. Now, for those of you that have never used Python before, here's what I'm doing. When I type df and then I type equals, basically I've just declared a variable. So df stands for data frame. Where did I get that? Honestly, I just made it up. I could type anything I want as a variable, and as long as I remember that variable name, I can use it over and over again. So basically I'm saying, hey, df equals, and I'm going to say pd. Why pd? Because remember, I created pd as an alias for the word pandas. And I'm going to do read _ Excel, and then inside this method here, I'm going to do /content. Oh, this is always hard to remember. /drive. Remember, and I just showed it to you. /my drive, and I got to make sure I get that right. /regression /home prices. Don't be alarmed if I spelled something wrong here. If I did, I'll go back and we'll get that working here. But when you're typing out these long paths, sometimes we get lucky on the first attempt. And so we did. So now before we continue, let's explain what that just did. Okay. So I declared a variable called a data frame. Okay. Now that data frame is basically the worksheet inside that Excel workbook that I just showed you in Excel, right? The home prices workbook. So now all I did was I said, we're going to use Pandas to read an Excel file, and the Excel file is located here. Okay. Now I just showed it to you, right? Because we use Google Colab to mount our Google Drive. Okay. And I've got content, drive, right? So we're in this whole content. There's my drive. Then we've got my drive, the regression folder, home prices, XLS file. Now at this point, we're ready to start cooking. So watch this. If I hit DF for data frame, there it is. That's the same file, right? Okay. Now there's some problems in here that will eventually give us grief, which I'll fix in a little bit. But for now, let me just show you a few cool tricks that you can do with data frames in Pandas. So the first thing is, if I do head, and this is a very small file, but if I do df.head, it's going to show me that data. Okay. So now what's the difference between what I did here with data frame versus df head? So if I did data frame, it's going to basically give you everything. Keep in mind, there's only 7 rows of data that you see here. Now, one thing that will confuse you with Excel versus working with Pandas is in a lot of languages, you don't start with 1, you start with 0. So for the first row, see it's counting. There's actually 7 rows of data, but it started with 0 instead of starting with 1. And this is not in your original data. This is just part of Pandas. So your data is column here, a column here. Okay. And when I do df head, it's going to show you the first 5 rows of data. I can also do df.tail, which is going to show you the end of the data. Okay. So the top and the bottoms of your data set. Now for this data, there's not that much, but for your group project, you know, there's 60,000 lines of data for your group project. So this is where tail and head really kind of play a role that's pretty handy here. Okay. So now there's a couple other things that you can do with data frames that are pretty cool. And in this data, it's pretty good. But in other data, you may want to work with it, which is df is, so you can do data frame. And again, that's just the name of the variable that I just created. And I could have called it anything, right? So I could have called it data, and I would type data dot is in A, like so. So as of right now, see how it says false, 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 false. That's because there are no values in our data set that are in A. That's what that means, right? So that's what all those falses are. So if there was missing data, it would give you a true anywhere in a field where there was data that's missing. And that would be a good thing to check before you continue, because you really can't have missing data. You have to figure out what you want to do with that data. Now I've got another trick that you can do. So we can do df.is null. And that's going to basically do the same thing. So is it blank? Is it an A? Is it a value, like a not a number value? Because you'll get that too. Those are things that you would want to deal with. Okay. So now we're about to have a headache here, and I'm going to go back and show you what it is. The headache is there's a space where it says square footage, and we can work with that, but it's a lot easier if we don't do that, if we don't have to deal with things that have spaces. So what I'm going to do is I'm going to use another little trick with data frames and pandas to rename the square footage column square footage, but with an underscore instead, so we don't have to deal with that space, which we can, but it's easier to not. So I'm going to show you another fun one we can do. So by the way, if you did take Visual Basic class, you talked about the object method concept of programming. Well, this is basically that, right? So df is the object, and I'm about to use the method rename, which, by the way, I spelled wrong. There we go, but it corrected me. Okay, so the data frame object rename method. And what we're going to do is we're going to go left parentheses, and we're going to take the columns. We're going to take a square bracket here. Nope. Squiggly square bracket. And we're going to take the square footage column that's got a space in it. And we're going to then put a colon, and we're going to tell it what we want it to rename it. So we're going to rename it square underscore footage, and that fixes a lot of our issues with spaces, and we don't have to worry about it. Now, we're not quite done here. We want this to stay. So if we want this to stay when we rename it, we're going to go in place equals true. Okay, cross our fingers. And now, how do we know if this worked? Well, let's look at our data frame. And look at that. Easy as pie, right? So probably not as easy as Excel, but in a minute, you're going to see some really cool things that we can do that will make this a little bit more interesting. So what we want to do now is we want to create that same scatter plot that we had inside Excel. And I think I've closed it so you can't see it now, but I'm going to go ahead and create it now. So let me show you a few ways to do that. So we're going to use something called matplotlib. And matplotlib is basically just a charting tool that's inside Python that we can use. But we're going to, oh, sorry, it auto-completed. Let's just make this go away and try again. So we're going to click Shift Enter. And now we've got that new line here. So what I did, by the way, is it auto-completed something that I didn't want it to auto-complete. So just like Excel, you have a similar type of IntelliSense when you're working in Jupyter Notebooks using Google Colab. And I typed inline here, and I wasn't paying attention, and it inserted interval index, which is not what I wanted. So we're going to do inline, and it did it again. Son of a gun. There we go. Let's not have that happen again. Okay, so from there, what we want to do is create a scatter plot, right? So remember, we created an alias for matplotlib called PLT. So I'm saying PLT.scatter, and that's going to start creating that scatter plot that we just created, okay, or that we want to create. Okay, so PLD scatter. So now inside this scatter chart, we have an X and we have a Y. Right? Just like we would have in Excel. We have an X value and we have a Y value. So the X value that we're going to work with here is going to be our square footage, and the Y value is going to be our values. Okay. So what I'm going to do is I'm going to take that data frame variable that I just created before, and I'm going to say that the data frame variable that we want is the square footage field inside our data set, the square footage column. Okay, and I'm going to say that I want my Y values to be my df dot values column, capital V. By the way, this is case sensitive, so you do want to pay attention. And for there, at that point, I believe we could still go ahead and do this. And there it is. Now we could make this a little cooler. And if you remember, I showed you at the beginning of the video, I showed you Excel. But we could make this a little cooler. So here's some fun things we can do here. So I can go in and I can add additional labels here. So I could say PLT, which again is the alias, X label is, we're going to call it actual square SQFT for square footage. Like so. And then we're going to do, you can make it whatever you want. So we could say font size equals 10. That may be small, but you get where we're going. Okay. And I'll do the same thing for my other axis. So PLT Y label, right? So this is my Y axis label, and we'll call this value, and we'll do font size 10 again. That's probably good. Nope, we did something wrong. We got a typo and it told us see. So this happens to everyone. So don't let this panic you when you're getting started. So I'm trying to think and type at the same time, and I had a typo, right? So I had my PLT variable for X label, which was right. And you see what I did? I had a PLY, which is a typo here. How did I know so quickly? It just told me. It said, hey, there is no variable or alias called PLY. So I'm going to jump in here and I'm going to debug. Real simple. And there we go, right? We've labeled value, we've labeled square footage, we're cooking. Easy, 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 easy. Okay. So at this point, we know we've got that linear relationship. Everything's looking good. Now is the part that's sort of new to you. Okay. New to you. So what we need to do is we're going to use that sklearn, that scikit-learn, to create linear regression. We're going to use the linear model that's included inside that library. So what I need to do is I'm going to start by creating an object, basically a variable that I can call to do different things. So I'm going to say regression, and we'll just call it an object like so. And I'm going to say that the regression object, so if I want to do the regression, is going to be linear underscore model dot linear regression with nothing in the parentheses, right? So I've got linear model that I've called, and I'm going to use specifically linear regression. Now I'm not quite done because now I still have to actually train the data. Like I have to fit the data to this regression model. So I'm not going to hit Control Shift Enter. I'm just going to hit Enter, and it's going to take me to the next line. And I need to do regression object, which by the way, you probably want to call this something different. I'm saying object just so you know, like, hey, this is specifically what we've just created. And we're going to use the method .fit. Okay. And now I'm going to have to fit a few things in. So I'm going to take that data frame that we were just working with, and I need to do square footage. And I'm going to go back and show you something with square footage in a second, because right now it's not going to work the way I just typed this in. And then I'm going to do data frame dot value. So that's my X and that's my Y. Okay. Now, right now it's going to yell at me as soon as I do this. Yep. See that? It yelled at me. So the reason it yelled at me when I did this is because for the X value, it's looking for a specific, for a two-dimensional array. So what I'm going to do is I'm going to jump in here and I need to put my X value inside double square brackets like so. And let's see if that got it. Oh, what did I miss? Right here's what I've done wrong. And you see it actually told me what I did wrong here. So boom, right there. That single quotation mark needs to actually go right there, like so. No, oh no, we're so close. All right, hold on. Let's see. We're going to debug a little bit more. Let's see what we're missing here. So we're going to regression object fit data frame. Oh, there it is. There's another one. See it? So lowercase s should be a capital S. Ta-da! There we go. Man, I'll tell you what. So even the best of us, and by no means will I say I'm a master of working in Python. This is a newer skill set for me. I was a Visual Basic guy for a long time. And obviously I'm a big Excel guy, but this is a cool new set of things that we can do here. So at this point, we're actually fairly done. Okay, we're fairly done here. So here's what I can do. Remember what we just did in Excel just a minute ago? Okay, I have the ability to actually call this function that I just created. So I can use this model that was just created. So I've used the X of square footage and the Y of value in order to actually calculate what the value of our house would be based on our data. So I could go regression object. Remember, I just created that. And I'm going to use the method predict. Yes, there we go. I'm going to use the method predict, and I'm going to go 5,000, which is what we just did in Excel, right? And we're going to cross our fingers. I haven't typed anything wrong. And there it is. Okay, so don't worry about the message that you've gotten here. See right down here? That's going to be very close to what we just had in Excel. Now, the difference with what we got in Excel versus the difference that we have here is that I shortened the numbers. So they were floating point values that were probably 10 or 12 decimal points deep in the coefficient and the intercept that we calculated in Excel. I didn't do that. I rounded them off, so I got a slightly different number. But basically now I am using this model. So I'm saying, hey, I have a house that's 5,000 square feet. What do you think the price should be? I can do it again. So I can jump back here. I can go regression object dot predict. And let's take a 3,250 square foot house. And there it's telling me it should be 371,882. Now I showed you in Excel in a previous video, I showed you that you have a slope function that you can use in Excel, and you also have an intercept function that you can use in Excel. You have those same functions that you can use inside Python when you're using this library. So I can go regression object dot intercept, and hopefully it'll tell me the intercept. And I can do the same thing, except instead of calling it a slope, we'll call it a coefficient. So coef. Uh-oh. I spelled something wrong. I left an S out of regression. You see that? And there you go. There's that 99.63. Okay, note, see all these floating points, how far out it's going inside Python versus what I had in Excel. So in Excel, it rounded off to 99.64. Here it went way, 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 way down. So there's the difference. That's what you have going on there. Okay. So at this point, that's a good place for us to stop. That's a good introduction to what we were working on. And I'm going to go ahead and save this. And by no means did I make this up. This particular example has been around forever. It's a really common way to get introduced into regression when working with something outside of Excel or an SPSS or something of that nature. It's not horribly hard. Now, when I look up at the calendar at my timer, it says it's been 30 minutes, but that's 30 minutes with me explaining it. So that makes life not horribly difficult in the grand scheme of things. So between now and tomorrow, because as of today, it's Easter, I would say give this a shot. Try going to colab.research.google.com, take that data set that was on Canvas, drop it in, And if you can't find it or if you don't know where to go, you could always just make your own, right? Just make up your own set of data, pop that in, and try it. Give it a shot. Try to create. And what I'll do is I've got a couple other videos I can show you or create to show you how to take a bunch of data that already exists in a worksheet and run that data through the model. So I can do like a bulk process, like a bulk prediction of however many you want, and I can save that back to that Excel file or CSV, which is pretty nifty. I also want to show you a couple other ways that you can do this and a couple other more advanced techniques to test our model using TensorFlow and then using a different methodology with a training set and a testing set and a few other things. The one thing I want to put on your docket before you just jump right in is that we were using continuous or numerical values here. So we were using values that were numerical in nature and not discrete. So they weren't necessarily categories. So if you look at the data set that's in your group project, or just data sets in general that have categorical data doesn't play well with you just trying to spit it into a regression. You have to do something with categorical data called one-hot encoding. Basically, you have to translate it into a numerical value that a machine learning model could understand as data. And you have to be careful when you do that, because remember, we have nominal, ordinal, interval, and ratio. If you just do something like a 1, 2, 3, or anything that's one category is a 1, then anything that's a second category is a 2, or a third category is a 3, that doesn't really work with nominal data. It could work, I suppose, with ordinal data. Think like freshman, sophomore, junior. Freshman's a 1, sophomore's a 2, junior's a 3. Like maybe that could work. Maybe, but really it's not a good way to be. So what you want to do is go back in and do something called one-hot encoding, and I'll show you that on the next video. It sounds crazy. It's easy to understand, and there's a lot of libraries that will do it for you. sklearn can do it for you. TensorFlow can do it for you. PyTorch can. There's a bunch of them out there that can make that work. So we'll do that in the next one. For now, enjoy your holiday. I wanted to get this in. My family's coming too, and I will see you guys very, very soon. Have a good one.